Okay, welcome back. In this particular video, we're going to learn how to find the periodic deposit and how much of a financial goal comes from the deposits and how much comes from interest. So we are going to start with some information that is given. Number one, we don't know what the periodic deposit is. So that's going to be a question mark, right? Because that's what we're going to find. And then some information, the rate is going to be assigned to 7% compounded daily, or annually rather. And the time is going to be for 16 years. And the goal, financial goal, will be 130,000. Okay? So we need to use a formula. All right. And it's going to be this right here. Oops. Okay. And I'll explain what it is. So the periodic deposit will be assigned to this formula. Okay, the future value would be A, the R would be the rate, and the N would be the number of times this money is compounded. So when we look over here, it's compounded annually. Okay, then that's going to be N equals 1. Okay, if it were compounded semi-annually, it'll be 2. Quarterly, it'll be 4, etc., etc. So we're going to use this formula, okay, to find A instead of the first provided formula. There are 3 other formulas that we use. So in this particular formula, we're going to use this value because this is the formula to use to calculate periodic deposit with the letter P. So anytime they mention periodic deposit, we need to use the following formula. Okay, so now it's a matter of plugging in the given information. Okay, and we know that we know some information already. So we're going to plug it in. All right, A is going to be 130,000. Okay, and that's going to be multiplied by the rate. Now we're going to make the percent into a decimal. So when you move it over 2 places to the right, you will get 0.07. And we're going to divide that by 1 because it's only compounded annually. Okay, take that whole thing. And we're going to add, we're going to do 1 plus the rate, which is 0.07 divided by 1. We're going to raise that to the nt power. So remember, n is 1, t is time for 16 years. So if time is 16 years and n is 1, then n times t would be 16, right? 16 times 1 is just 16. So we'll go ahead and do that now. All right. So remember, nt equals 16 times 1. Okay? So that's the time, and that's n. All right, so now it's just a matter of calculating everything. So when we do that, okay, we have to do this in order of operations. Okay? So, and then we'll get our answer. So let's go ahead and do that. Okay, so let's continue on to the next slide, and we'll go ahead and do the calculation. Okay, so remember that we had 130,000. Okay, oops. We had 130,000 for A. And when we do 0.07 times 1, okay, we are going to get the following number. So just give me one moment. Okay. Obviously, it's going to be 0.07. Anything divided by 1 is just that same quantity back. Okay, and then we're going to do this calculation. So, if we do 1 plus 0.07 divided by 1, well, like I said, we've already determined what 0.07 divided by 1 is. You add the 1, and then you're going to get 1.07. Okay, we're going to raise that to the 16th power, subtract 1, and then we'll be good to go. All right, so let's go ahead and finish the calculation, and we'll get our answer. Okay, gives me $4,661.49, or to the nearest dollar, $4,661. So that would be that amount. And then the periodic deposit, okay, excuse me, that is the periodic deposit. Okay, so we got P equals this number here. Now for part B, we want the interest. Okay, what would we want for part B? We want this question here. What is the financial goal? So what we're going to do is the interest is the difference between the value of the annuity and the total amount deposited. So the total amount deposited over 16 years is $74,592. So basically, how to do that, how to come up with that figure is. So remember, the $4,661 is the amount deposited every year, and if you times that by 16 years, you'll get the value of $74,583.84. And it also depends on how many place values you're using here. So if you truncate some decimal places as you're going along with the calculation, your values will be a little bit less accurate. So try not to round as you do these calculations. If you think you made an error, just go back and redo the calculation, check your calculator and see if you're missing a digit or you wrote down a wrong digit, which can easily happen here when you do this type of number crunching, as I like to call it. So that is what I got from that. Okay, so we have 16 years times $4,661.49 will give me the $74,583.84. Okay, and then you just take the difference, the amount from the value of the annuity, which is $130,000, in order to find the interest. So take the difference of $130,000. And we're going to subtract the $74,583, and that'll give us what the future interest is going to be. Okay, the whatever we get is going to come from the deposits, and an X amount of dollars will come from the interest, and that's what we're calculating here. Okay, so let's go ahead and do that. Okay, so this is how much comes from the interest, $55,416.15. Just a point to clear up, if you get a value, an exact answer, like this is what it would be, if they want you to round to the nearest dollar, okay, the value will be a little bit different, okay? So keep that in mind. Read, when you do problems like this, if you're ever given an assignment like this, read the directions carefully and see how they want the final answer. Do they want you to approximate, round off to the nearest whole dollar or cent, things like that, okay? So just a little FYI to pass along with you just in case there's any confusion. Okay, so that concludes that problem. And let's see if we can go ahead and do one where we calculate, we find the periodic deposit, and let's do a different situation where it's compounded a little differently. Let's go ahead and do the next slide. Let's create a situation where we want to find the following. So let me go ahead and present a problem where we're going to find the value that you'll have in an IRA when you retire at the age of 65 and its interest. Okay, so let's go ahead and do that. Okay, and just so you know, for informational purposes, an IRA stands for Individual Retirement Account, and it promotes savings for retirement by providing various tax advantages. So one of the main reasons that people invest in IRAs is it can be a supplement to your employer sponsored retirement plan. So, and it gives you a broader spectrum of investments than your employer may have. So that's what it is, and that's what it means. And let's go ahead and calculate this. We're going to use the following formula. Okay, so let me go ahead and write this down. Okay, it's kind of similar to some degree, but it's a little slightly different. Parameters remain the same. So why do we have to use this formula than the previous one? Well, in those states, A stands for future, well, A means future value in this case. We want to know how much we'll need when you retire at the age of 65. So 36 is present, and then 65 will be in the future. You're finding the future value of how much you will have at that retirement age. So that's what A is, and we use this formula in addition to, because I don't know if that last sentence made sense, but we use this formula if the money is compounded more than once a year, and it's clearly telling me that it's monthly at the end of each month. Okay? So how many times it's compounded, will determine what formula you're using, and when it's presented like this, you got to think of future value, and it's compounded monthly. So we're going to use this formula. Okay? So in this particular problem, you're going to be very careful because the N times T is going to be much larger. So let's see the information that is given. We know the rate is, let's see if I want to put it here. Okay, so let's just put it here. So let's say the rate is 3.5%. Convert that to a decimal, okay, you should get 0.035, okay? And then N is going to be monthly. It's going to be 12, okay? 12 months. Now when you find N, okay, don't forget that if you take the difference between 65 minus 36, that'll give you the amount of years from 36 to 65, okay, which is going to be 29. And then you take 29 and times that by 12 months in each year, okay? That's going to give you 348. Okay? So make sure you keep that in mind, and you'll have that answer. Okay, so N's going to be 348. And the time has already been accounted for, okay, because of the 29 years difference in between 36 and 65, so that's your time, and then you times it by 12 months, 12 years. 12 months, right? Every year is 12 months, and you times that by 29, you got 348. So make sure you substitute that for n times t. All right, let's go ahead and do this. So we know the initial value p is, we could put that down here. P is going to be 50. Okay, so we have 50, and we're going to multiply that 1 plus, now r is 0.035. We're dividing that by n, 348. Raised to the 348 power, subtract 1. And then r is 0.035 divided by 348. So now let me do the calculations and see what we get for an answer. Okay, just a little correction. Time should be 12 because it's being compounded monthly, so we have to put in 12. And then we do the calculation for n times t, which is 348. So I just wanted to clarify that and correct that. Make sure that we understand that it's compounded 12. Okay, so if I rewrite it like this, technically this here, n times t, is equal to 348. And n over here is going to be 29, okay? And then when you multiply it, n is going to be 12. N is going to be 12 because of the monthly value, okay? All right, so this calculation I did on the lower left is not n, it's n times t. Because you're taking the difference between 65 and 36 years of age, you get 29, you times it by 12 months for each year, okay, and then you get 348, okay, but the actual n value is 12 from the problem, compounded monthly. So, all right, just wanted to clarify that confusion, make sure everybody's on the same page. And then now the calculation that I did, okay, and then just do all the calculations. And I got $30,091. Notice it's rounded up to the nearest dollar because that's what the problem was asking for. And now, in order to do the second part, the interest is the difference between the value of the annuity, okay, which is $30,091, and we subtract the total amount deposited. So remember, over a period of 29 years, we have to times it by 12 months, and then you times it by the initial value of $50. So you will get $17,400 when you do that. Okay, so now we take the $50, multiply that by 12 months times 29 years, and you will get 17,400. And then when you do the interest, don't forget the interest is, okay, let me just write this down for you. The interest equals the value of the annuity and we're going to subtract the total deposits, which is the 17,400 value. Okay, so what this is going to be is when you do that, you get $30,091, subtract 17,400, and you will get $12,691. Okay, and that's how you do a problem like that. Okay, so let's go to the next slide to sum up what formulas to use based on the situation that's provided to you. The very first equation is we use A equals P 1 plus R to the T power minus 1 divided by R. We use this equation for the value of an annuity compounded annually. So this is when the annuity is compounded annually. Okay, and the next formula is this one. And we've used that a little bit earlier in the previous problems. Okay, 1 plus R over N raised to the NT power minus 1, close bracket, all over R minus N. We use this particular formula. We find the value of the annuity when it's compounded more than once a year. Okay? The value when it is compounded more than once a year. And finally, we have this equation. Oops, let me just fix that. Okay, and this particular equation is used to find the periodic value. Okay. Periodic deposit. So that's how you know what formula to use for each problem that's given to you. Okay, this is a very important piece of information that I'm giving you. Once you understand this, refer back to this formula sheet, if you will, or slide, and then you should be able to do just about any type of problem that's presented for this particular topic. Okay, hopefully this was very helpful, and I'll see you in the next video.